Hello everyone, welcome for this online session of Biostatistic. Today we will see the statistical hypothesis and test of significance. So let us start with the lecture. So these are the learning outcomes. After attending this video session, you will be able to understand and explain the statistical hypothesis in detail, and you will be able to summarize some statistical tests. Now we will see the statistical hypothesis. So first of all, what is hypothesis? So hypothesis means what? When we are going to start some research study, we should first make some assumptions, and that assumptions are known as hypothesis. Means what? Assumption, or you can say some suppositions to be proved, or you can say disproved, but we should make that assumption, and that is known as hypothesis. Now what is statistical hypothesis? So a hypothesis that are stated in such a way that they may be evaluated by appropriate statistical techniques, and that is statistical hypothesis. Now these hypotheses are divided into two types: null hypothesis and alternative hypothesis. So what is null hypothesis? Null hypothesis means what? Here, whatever assumption we made that is equal to our population mean, means after getting a result of our research, it will be matched with our hypothesis. That is, here this mu is a population mean. Means what? Whatever. See, here this mu1 means a population mean and is equal to this mu2. Means you can say whatever assumption we made that will prove our result, and that is known as null hypothesis. But what is alternative hypothesis? It is denoted by HA. Here this is denoted by this H0, and this is the hypothesis that differs from null hypothesis. Means what? Null hypothesis means whatever assumption we made that is equal to our result. We are getting result as per the assumption. But what is alternative? Alternative means simple, we are not getting a result as per our assumption. Means here whatever value we will get that is not equal to our assumption, or you can say our assumption is higher than our population mean. This mu means population mean, or you can say assumption is lower than our population mean. So this is all about alternative hypothesis and null hypothesis. We will see by some example what is null and alternative hypothesis. So suppose we want to test the hypothesis that the population mean mu is equal to hypothesized mean, or you can say this hypothesized mean mu is equal to 100. Means what? H0 means our hypothesized mean, means this mu. Means what? Whatever assumption we made, our assumption is our population mean should be 100. Then we would say that the null hypothesis is that the population mean is equal to hypothesized mean 100. Means here we are getting a result. So symbolically we can express as this is the null hypothesis. Mu is equal to mu H0, means population mean is equal to hypothesized population mean, that is 100. Now what is alternative hypothesis? So if our sample results do not support this null hypothesis, we should conclude that something else is true. This kind of result we will get. So what we conclude rejecting the null hypothesis is known as alternative hypothesis. when there is a rejection of null hypothesis, it will always be an alternative hypothesis. Now we will see level of significance. Now what is level of significance? See, this is very important concept when there is a hypothesis testing. When we are testing hypothesis, how we can test hypothesis? So it is always some percentage, right? And that is known as a p-value. So what is p-value? It is a function of observed sample results that is used for testing a statistical hypothesis. It is a probability of null hypothesis being true. P-value is nothing but a probability, and it can accept or reject the null hypothesis based on p-value. How we can test our hypothesis, that is p-value, and it will always be given in a percentage. So here that percentage is 5%. Means you can say the 5% level of significance means what? The researcher is willing to take as much as 5% risk of rejecting the null hypothesis, and when it happens to be true. Thus, the significance level is maximum value of a probability of rejecting the null hypothesis when it is true, and is usually determined by some testing of the hypothesis. So it's in percentage, it is 5%, so it will be less than, it should be less than 0.05%. Now this p is equal to, if there is 0.05, it implies we may go wrong 5 out of 100 times by rejecting null hypothesis, or you can say we can attribute the significance with 95% confidence. Means 5% risk we can take, not more than that. If our risk is more than that, then our null hypothesis will be rejected, and if it will be less than that, means it will be accepted. So this is known as a level of significance. Now we will see the hypothesis errors. So the hypothesis errors are of a two type. See, as I have discussed about a probability, or we can say the level of significance. So what is error? So it's divided into two types, type 1 error and type 2 error. So what is type 1 error? Here we can say that we may reject null hypothesis when it is true, okay, or there are two possibilities. We may reject null hypothesis when hypothesis is true, or we may accept null hypothesis when it is not true, right? There are two possibilities because we are making assumptions only. So what is type 1 error? We can say that type 1 error means rejection of hypothesis which should have been accepted, and here we may accept when in fact it's not true. Means what? Type 2 error means you can say that we are accepting the hypothesis which should have been rejected. So this is the difference between type 1 error and 2 error. In type 1 error, what are we doing? There is a rejection of hypothesis which should have been accepted, and here there is an acceptance of hypothesis which should have been rejected. So this is known as alpha error, or you can say false positive error. But here beta error, you can say it is known as false negative error, because here we are accepting negative thing. That's why it is known as false negative error. Now, see, these are the parameters. This H0 means null hypothesis, it's true and false, right? So this is a decision. Means here there is an acceptance of null hypothesis and rejection of null hypothesis. So when our hypothesis is true and we are accepting hypothesis, it is our correct decision. And when we are making error, when there will be error, when our hypothesis is true but it will come to rejection, then it will produce type 1 error. But what happens when our hypothesis is false but we are accepting that hypothesis, then it is type 2 error. But at that time, what is our correct decision? We have to reject, but we are accepting. So this is known as type 2 error. So this is a false negative error. Now we will see the critical region. See, there are two type of region, means two kind of test we can do as a statistical test, that is a one-tailed test and two-tailed test. It will also known as one-sided test and two-sided test. Now what is one-tailed test? Means what? Here the rejection is in one or other tail of distribution. The difference could only be there in a one direction. Here there is a difference in only one direction. For example, Englishmen are taller than Indian men. Only one difference. In one direction there is a difference, that Englishmen are taller than Indian men. And what is two-tailed test? It will get more clear. The rejection is split between the tails of distribution. Means it is a two-sided. The difference could be in a both direction. In both sides there will be a difference. For example, if you are doing comparative study of drug X, means any of the drug, with atenolol for antihypertensive property, there will be a difference from the property of this atenolol as well as this drug X. That's why it is known as two-tailed test. There is a difference in a two direction, but here there is a difference in only a one direction. Now we will see in detail. See here, we can see this is a one-tailed critical region. It's denoted by, or it's explained by this two chart. Means what? Here one, as a left hand side there is a critical region, means probability should be 0.05%. Here also on the right hand side we are getting this, and this is a one-tailed critical region and this is a two-tailed critical region. Means at both sides there is a possibility of 0.025 and 0.025. We will see in detail what is it. Now see, first we will see the two-tailed test. Means what? What is two-tailed test? So a two-tailed test rejects the null hypothesis. If say the sample mean is significantly higher or lower than hypothesized value of a mean of the population. When this is possible, the sample mean is higher or lower than hypothesized value of the mean of population. Such a test is appropriate when null hypothesis is some specified value and the alternative hypothesis is a value not equal to specified value of a null hypothesis. Means when this test will get appropriate when H0 should have some specific value. Here it will be clear by this diagram. We can see this is the acceptance and rejection regions in case of two-tailed test, right? With a 5% significance level. So here you can see this is a rejection. Here also this is a rejection region. So this is a two-tailed test, means on both sides there should be a chance of a rejection. And here this is a acceptance region, means accept, when we will accept at 0. If the sample mean falls in this region, then it will be accepted. But outside of this region, it will be rejected. So now see, both taken together equal 0.95 or 95% of the area. Means here you can say this area is of a 95% and this is of a 5%, means 2.5 and 2.5%. Now when it will get rejected? So if the sample mean falls in either of these two regions, right, it will get rejected. So mathematically we can state that our acceptance region over here, if it will be less or equal to 1.96, then it will be accepted. But if it will be greater than, or you can say equal to 1.96, then it will be rejected. So it will be more clear by one-tailed test. Now, so what is one-tailed test? As we know, one-tailed tests are either, you can say, left-tailed test or right-tailed test. Now when it is known as, you can say, left-tailed test, so whether the population mean is lower than some hypothesized value, it is known as left-tailed test. Means what? Here you can see this is the region, this is the rejection region, and this is the acceptance region. So here this is the area include 0.05. Okay, so here the rejection if the sample mean falls in this region, but here it will be accepted. So accept at 0 if the sample mean falls in this region. Now mathematically we can say that when it will be accepted or when it will be rejected. So we will get this value lower than it will be accepted and greater means it will be rejected. Now what? Now the next is right-tailed test. Now what is right-tailed test? So whether the population mean is higher than some hypothesized value, it is known as right-tailed test. Means what? Here you can see at the right side there is a rejection region. That's why it is known as right-tailed test. Means our rejection, means our hypothesis will be rejected if the sample mean follow in this region. Mathematically it is totally opposite of a left-tailed test. Now we will see the procedure for hypothesis testing. How we can do hypothesis testing? What are the steps of hypothesis testing? So first step is making a formal statement. What does it mean? Means what? Always our hypothesis should be clearly stated. We can consider our nature of the research problem and we should make a clear statement of our hypothesis. This is the very first step of hypothesis testing. After that, selecting a significance level. Means as I have discussed the probability value, the hypotheses are tested on a predetermined level of significance. As such, the same should be specified. Generally, for example, either 5% or 1% level is accepted for this purpose. And the factors, some factors which is affected to select a significance level. For example, you can say the size of sample, variability of measurement within the sample, Then whether the hypothesis is a directional or non-directional. This is also a consideration. Then after selecting a significance level, 5% or 1%, there will be a third step of deciding the distribution to use. This is a very important step. Means here this step is to determine the appropriate sampling distribution. Means the choice will generally remain between normal distribution and t distribution. It will be clear by t-test. Now the next is selecting. After deciding the distribution, we have to select a random sample and computing an appropriate value. Means we have to select a random sample and compute an appropriate value from the sample data. Then the next is calculation of probability. Means what? We should calculate the result, the p-value. Means we have to apply our significance of test for the hypothesis. Now next is after calculation of probability. Now we will get our value. After that, comparing the probability. Means now we are able to find if it's come under significance level or is there any error. You can say alpha error or beta error, or you can say one-tailed test or two-tailed test. So this is all about procedure for hypothesis testing. In the next lecture, we will see the statistical testing. Thank you, dear learners. If you have any doubt, you can email me on this email ID, or if you have any doubt, you can contact me. You can WhatsApp me on this number. Thank you. Happy learning.